Charles Darwin, one of the most influential figures in the history of science, was born on February 12, 1809, in Shrewsbury, England. His family was affluent and intellectually accomplished, providing a nurturing environment for his early education. Charles was the fifth of 6 children born to Robert Darwin, a successful physician and financier, and Susanna Wedgwood, the daughter of the prominent Wedgwood pottery family. This background afforded him a privileged upbringing and exposure to progressive ideas, shaping the foundations of his intellectual journey. As a child, Darwin exhibited a keen interest in the natural world, often collecting insects, shells, and other specimens from the surrounding countryside. However, his early academic performance was unremarkable. Enrolled at Shrewsbury School, a traditional boarding school focused on classical education, Charles struggled to engage with subjects like Latin and Greek. His teachers regarded him as an average student, though his curiosity about nature hinted at his potential. In 1825, at the age of 16, Darwin began studying medicine at the University of Edinburgh, following in the footsteps of his father and grandfather. Despite the prestige of the institution, Charles found himself uninterested in medical lectures and deeply disturbed by the gruesome realities of surgery, which was performed without anesthesia at the time. This aversion led him to neglect his medical studies and instead immerse himself in extracurricular pursuits, such as taxidermy and marine biology. During his time in Edinburgh, Darwin joined the Plinian Society, a student group dedicated to discussing scientific ideas. Here, he encountered radical thinkers who questioned traditional views of science and religion. This exposure expanded his horizons and introduced him to emerging concepts in geology and natural history. One of his mentors, Dr. Robert Grant, encouraged him to study marine invertebrates, sparking his first scientific research on the life cycles of sea creatures. Realizing that a career in medicine was unlikely to suit him, Darwin's father arranged for him to study for the clergy at the University of Cambridge. In 1828, Charles enrolled at Christ's College with the aim of becoming an Anglican clergyman. While theology was the official focus of his studies, Darwin's passion for natural history continued to grow. He developed friendships with influential figures such as John Stevens Henslow, a botanist who became a lifelong mentor. Under Henslow's guidance, Darwin honed his skills in observation and specimen collection. Henslow introduced him to the works of renowned scientists, including Alexander von Humboldt and Charles Lyell, whose ideas about geology and the age of the Earth would profoundly influence Darwin's thinking. These intellectual connections transformed his experience at Cambridge from a mere clerical education into an informal apprenticeship in natural science. During his time at Cambridge, Darwin also excelled in extracurricular activities. He became an avid collector of beetles, earning recognition among entomologists for his discoveries. This hobby not only demonstrated his meticulous attention to detail, but also reflected his deepening fascination with the diversity of life. His enthusiasm for nature gradually overshadowed his theological studies, signaling a shift in his future aspirations. After graduating from Cambridge in 1831, Darwin faced uncertainty about his career path. A pivotal moment came when Henslow recommended him for a position as a naturalist aboard HMS Beagle, a survey ship preparing for a voyage to South America. Although initially hesitant, Darwin accepted the opportunity, marking the beginning of a transformative journey. Darwin's early life and education laid the groundwork for his scientific achievements. His struggles with traditional schooling, combined with his self-directed exploration of natural history, shaped a unique intellectual trajectory. By the time he boarded the Beagle, Darwin was well prepared to observe the natural world with a critical eye and a passion for discovery. His formative years, marked by curiosity and mentorship, would soon culminate in groundbreaking contributions to science and our understanding of life itself. The voyage of HMS Beagle marked a turning point in Charles Darwin's life and career, transforming him from an aspiring naturalist into one of the most influential scientific thinkers in history. This journey, which began in December 1831 and lasted nearly 5 years, provided Darwin with the first-hand observations and experiences that would later form the foundation of his theory of evolution by natural selection. When Darwin was invited to join the Beagle as a naturalist and companion to Captain Robert Fitzroy, he was initially uncertain about accepting the offer. The voyage was expected to be arduous, and Darwin's father initially opposed the idea, viewing it as a distraction from his son's pursuit of a respectable career. However, after persuasion from his uncle, Josiah Wedgwood, Darwin secured his father's approval and prepared for the expedition. The opportunity was unparalleled. The Beagle's mission was to chart the coastlines of South America, and Darwin would have the chance to study the natural history of regions largely unexplored by European scientists. The Beagle set sail from Plymouth on December 27, 1831. Darwin's role as the ship's naturalist required him to collect specimens, document observations, and provide insights into the geology, flora, and fauna of the areas visited. Although seasickness plagued him throughout much of the journey, Darwin's enthusiasm for exploration never wavered. Armed with notebooks, scientific instruments, and guidance from his mentors, he approached his task with diligence and curiosity. One of the first significant stops was the Cape Verde Islands, where Darwin began to develop his interest in geology. He observed volcanic formations and collected samples, noting the layers of rock that suggested a dynamic history of change over time. These observations reinforced ideas he had encountered in Charles Lyell's Principles of Geology, a book he brought on the voyage and referred to frequently. Lyell's argument that geological features resulted from slow, gradual processes rather than sudden catastrophes deeply influenced Darwin's thinking. The Beagle's journey continued along the coast of South America, where Darwin's experiences expanded his understanding of biodiversity. In Brazil, he marveled at the lush tropical rainforests, recording detailed descriptions of the plants, animals, and insects he encountered. He was particularly struck by the immense variety of life and the intricate interdependence of organisms within ecosystems. These observations sowed the seeds of his later work on adaptation and the interconnectedness of species. Patagonia offered a stark contrast to the rainforests of Brazil. Here, Darwin examined fossils embedded in cliffs, uncovering the remains of extinct mammals such as giant ground sloths and armadillos. The discovery of these fossils raised questions about the causes of extinction and the relationship between ancient and modern species. Darwin began to speculate about the mechanisms driving such changes, though his ideas were still nascent at this stage. One of the most significant phases of the voyage occurred in the Galapagos Islands, a volcanic archipelago located off the coast of Ecuador. Darwin's observations of the island's unique wildlife, most notably the finches, tortoises, and marine iguanas, were pivotal in shaping his understanding of evolution. He noted that different islands hosted distinct species, each adapted to its specific environment. These variations hinted at the possibility that species were not fixed but could change over time, a revolutionary idea that challenged prevailing beliefs in the immutability of life forms. The Beagle's journey also brought Darwin into contact with diverse human cultures and ways of life. In Tierra del Fuego, he encountered indigenous peoples whose customs and lifestyles contrasted starkly with European norms. These interactions prompted Darwin to reflect on human diversity and the potential evolutionary explanations for cultural and physical differences among populations. Such reflections would later inform his work on human evolution and social behavior. Throughout the voyage, Darwin maintained a meticulous record of his observations, filling notebooks with descriptions, sketches, and hypotheses. He sent specimens and letters back to England, where they were eagerly received by his mentor John Stevens Henslow and other scientists. These communications helped establish Darwin's reputation as a keen and capable naturalist even before his return. By the time the Beagle returned to England in October 1836, Darwin had amassed an extraordinary collection of specimens and a wealth of data. The voyage had profoundly altered his worldview, providing him with compelling evidence that species were not static but subject to change over time. Although he did not yet have a fully developed theory of evolution, the seeds of his groundbreaking ideas had been firmly planted. The Beagle voyage was more than an adventure. It was an intellectual awakening for Darwin. It provided him with the empirical foundation to challenge long-held assumptions about the natural world and to embark on the intellectual journey that would culminate on the origin of species. This expedition, with its blend of discovery, observation, and reflection, became the cornerstone of Darwin's scientific legacy. The Galapagos Islands, a remote volcanic archipelago in the Pacific Ocean, played a pivotal role in shaping Charles Darwin's understanding of evolution. His observations during his visit in 1835 as part of the HMS Beagle's voyage laid the groundwork for his revolutionary ideas about the adaptability and variability of life. These islands, with their unique ecosystems and isolated populations, provided Darwin with a natural laboratory to study the processes of change and diversification among species. Darwin arrived at the Galapagos Islands in September 1835. He was immediately struck by the stark, rugged landscape and the apparent desolation of the islands. Despite their harsh environment, the islands teemed with life, much of it unlike anything Darwin had encountered elsewhere. He quickly recognized that the isolation of the archipelago had given rise to species that were not only unique to the islands, but also showed variations between different islands. One of Darwin's most significant observations concerned the finches that inhabited the islands. While Darwin initially paid little attention to these birds, he later realized that the finches varied in beak size and shape depending on the island they inhabited and the type of food available. Some finches had stout beaks suitable for cracking seeds, while others had slender beaks designed for extracting insects or nectar. These variations suggested that the finches had adapted to their specific environments over time, a concept that directly challenged the prevailing view of species as immutable. Similarly, Darwin noted the differences in the shell shapes of the Galapagos tortoises, which varied from island to island. On some islands, tortoises had domed shells, while on others, they exhibited saddle-shaped shells that allowed them to stretch their necks higher to reach food. Local inhabitants informed Darwin that they could identify the island of origin of a tortoise based solely on its shell shape. This observation further reinforced the idea that species could diverge in response to environmental pressures. Darwin also observed marine iguanas, which were unique in their ability to feed on underwater algae, a behavior not seen in their terrestrial relatives. These iguanas exhibited adaptations such as flattened tails for swimming and strong claws for clinging to rocks in the surf. Their existence was another testament to the role of isolation and environmental challenges in shaping the characteristics of species. In addition to his observations of animals, Darwin studied the island's plant life. He noted that while many plants were similar to those found on the mainland, they had developed distinct traits that allowed them to thrive in the island's arid conditions. The flora of the Galapagos further illustrated the principle that geographic isolation could lead to the emergence of new, adapted species. Darwin's observations in the Galapagos were not merely descriptive. They also prompted him to question the mechanisms behind the patterns he observed. Why did species vary so distinctly from one island to another? What forces drove these changes? Although Darwin did not yet have a fully formed theory of natural selection, he began to consider the possibility that species were not fixed entities but could change over time in response to their environment. This idea was radical for its time, challenging the dominant view of creationism and the belief in the permanence of species. Despite the significance of his findings, Darwin's conclusions were not immediate. It was only after he returned to England and began analyzing his specimens and notes that the implications of his Galapagos observations became clear. He consulted with experts, including ornithologist John Gould, who confirmed that the finches Darwin had collected represented distinct species. This revelation was a turning point, solidifying Darwin's realization that the variations he observed were evidence of evolutionary processes at work. The Galapagos Islands thus became central to Darwin's developing ideas about evolution. The isolation of the archipelago provided a unique setting in which species could diverge and adapt to specific ecological niches. These adaptations, in turn, offered tangible evidence that contradicted the static view of life and supported the idea of gradual, incremental change. In the years following his voyage, Darwin would revisit his Galapagos observations repeatedly as he refined his theory of natural selection. The finches, tortoises, and iguanas of the Galapagos became iconic examples of evolutionary processes, illustrating how isolation and environmental pressures could shape the diversity of life. The significance of the Galapagos in Darwin's work endures to this day. symbolizing the power of observation and the transformative potential of scientific inquiry. Darwin's time in the Galapagos was brief, but its impact was profound. The islands challenged his assumptions, inspired his curiosity, and provided the empirical foundation for his revolutionary ideas. In this isolated corner of the world, Darwin found the clues that would unlock the secrets of life's diversity, setting the stage for one of the most important scientific breakthroughs in history. Following his return from the voyage of the HMS Beagle in 1836, Charles Darwin began the painstaking process of analyzing the data and specimens he had collected during his travels. The seeds of his revolutionary ideas had been sown during his observations, but the development of the theory of natural selection required years of study, reflection, and synthesis. This chapter explores how Darwin gradually formulated his groundbreaking theory and the intellectual journey that led him to question the prevailing views on the immutability of species. Upon his return to England, Darwin became a rising star in the scientific community. His meticulous observations and the sheer volume of specimens he brought back from the Beagle voyage impressed his contemporaries. Initially, much of his work focused on geology, including studies of coral reefs and volcanic formations, which solidified his reputation as a careful and innovative scientist. However, Darwin's interest in the diversity of life remained paramount, and he began to study his collections more deeply, particularly the variations among species. One of the key influences on Darwin's thinking was the work of geologist Charles Lyell, whose Principles of Geology Darwin had read during the Beagle voyage. Lyell's arguments for gradual, observable processes shaping the Earth over immense periods of time inspired Darwin to consider whether similar principles could apply to the development of life. The concept of deep time provided the temporal framework necessary for gradual biological changes to accumulate into significant evolutionary transformations. Another critical influence was the work of Thomas Malthus, an economist whose essay on population dynamics profoundly impacted Darwin's thinking. Malthus argued that populations tend to grow exponentially while resources increase arithmetically, leading to competition and a struggle for survival. When Darwin read Malthus's work in 1838, he realized that this principle could apply to nature. In the face of limited resources, organisms better adapted to their environment would have a higher likelihood of surviving and reproducing, passing on their advantageous traits to future generations. With this insight, Darwin began to sketch the outlines of his theory. He hypothesized that natural selection, a process analogous to artificial selection practiced by breeders, could explain the evolution of species. Just as farmers selectively bred plants and animals to enhance desirable traits, nature could select individuals with traits that conferred a survival advantage in their specific environment. Over time, these incremental changes could lead to the emergence of new species. Darwin's work was characterized by meticulous observation and analysis. He conducted experiments in his garden, bred pigeons to study inheritance, and corresponded with scientists and naturalists worldwide to gather additional data. His observations of barnacles, which he studied intensively for several years, further refined his understanding of variation and adaptation. These efforts demonstrated Darwin's commitment to building a solid empirical foundation for his theory. Despite his growing confidence in the concept of natural selection, Darwin was acutely aware of the potential controversy his ideas would provoke. The prevailing view at the time, rooted in religious doctrine and supported by many scientists, held that species were created individually and remained fixed. Darwin's theory directly challenged this notion, proposing instead that all species shared common ancestry and evolved through natural processes. Darwin's caution also stemmed from the complexity of his theory. He recognized that natural selection could not explain every detail of life's diversity and that gaps in his knowledge, such as the mechanisms of inheritance, left room for criticism. These gaps would later be addressed by the rediscovery of Gregor Mendel's work on genetics, but during Darwin's time, they remained unresolved. By the early 1840s, Darwin had completed a detailed manuscript outlining his theory, but he refrained from publishing it. Instead, he continued to amass evidence, refining his ideas and strengthening his arguments. His decision to delay publication was partly driven by his desire to produce a comprehensive and irrefutable case, and partly by his apprehension about the potential backlash from both the scientific community and the public. The catalyst for Darwin's eventual decision to publish came in 1858 when he received a letter from Alfred Russel Wallace, a naturalist working in the Malay archipelago. Wallace had independently arrived at a theory of evolution strikingly similar to Darwin's, describing the role of natural selection in shaping species. This unexpected development spurred Darwin into action, and the two scientists presented their ideas jointly at a meeting of the Linnean Society in July 1858. Darwin then worked tirelessly to prepare his magnum opus on the origin of species by means of natural selection. Published in 1859, the book synthesized over 2 decades of research and observation, presenting a coherent and persuasive argument for evolution through natural selection. Its publication marked the culmination of Darwin's intellectual journey and the beginning of a profound shift in the scientific understanding of life. The development of the theory of natural selection was not a sudden revelation, but a gradual process of inquiry, reflection, and synthesis. Darwin's ability to integrate insights from diverse fields, his commitment to empirical evidence, and his willingness to challenge established ideas were crucial to his success. His journey from the observations made during the Beagle voyage to the publication of On the Origin of Species stands as a testament to the power of curiosity, perseverance, and scientific rigor. The publication of Charles Darwin's On the Origin of Species by means of natural selection in 1859 was a watershed moment in the history of science. The culmination of more than 2 decades of meticulous research and reflection, the book presented a compelling argument for evolution through natural selection. This chapter explores the context of its publication, the content of the work, and the immediate reactions it elicited from the scientific community and the broader public. Darwin's decision to publish was not made lightly. For years, he had hesitated to present his ideas to the world, aware of the controversy they would provoke. The prevailing view at the time, known as special creation, posited that all species were created separately and remained unchanging since their origin. This view, deeply intertwined with religious doctrine, stood in stark contrast to Darwin's proposition that species evolved through natural processes over vast periods of time. Darwin's own religious doubts and his desire to avoid alienating his peers made him cautious. The immediate impetus for publication came from Alfred Russel Wallace, a fellow naturalist who independently formulated a theory of evolution remarkably similar to Darwin's. In 1858, Wallace sent Darwin a manuscript outlining his ideas on natural selection. Recognizing the striking parallels with his own work, Darwin faced a dilemma. Encouraged by his peers, including Charles Lyell and Joseph Hooker, Darwin and Wallace presented their theories jointly at a meeting of the Linnean Society in London. Although the event attracted little attention at the time, it spurred Darwin to finalize and publish his comprehensive account. On the Origin of Species was published on November 24, 1859, by John Murray, a respected London publisher. The first edition, consisting of 1,250 copies, sold out on the first day, a testament to the public's curiosity and the anticipation surrounding Darwin's work. The book was not written for specialists alone. Darwin deliberately adopted a clear and accessible style, aiming to reach a broad audience. The central argument of origin was deceptively simple. Species were not fixed, but evolved over time through the process of natural selection. Darwin supported his claim with extensive evidence drawn from a variety of fields, including geology, paleontology, biogeography, and comparative anatomy. He emphasized the role of variation within populations and the competition for resources, explaining how advantageous traits became more common over successive generations. One of the most compelling aspects of Darwin's argument was his use of examples from artificial selection. He described how breeders of plants and animals had long manipulated traits through selective breeding, creating new varieties with desired characteristics. By drawing a parallel to nature, Darwin illustrated how similar processes could occur in the wild, driven by environmental pressures rather than human intervention. Despite its strengths, On the Origin of Species acknowledged gaps and limitations in the evidence. Darwin was forthright about the absence of transitional fossils in the geological record and the lack of a comprehensive understanding of heredity. He admitted these shortcomings while expressing confidence that future discoveries would fill in the gaps, a prediction that proved remarkably accurate with the subsequent development of genetics and molecular biology. The publication of Origin elicited a wide range of responses. Among scientists, the book found both ardent supporters and vocal critics. Many naturalists were persuaded by Darwin's evidence and arguments, recognizing the explanatory power of natural selection. However, others rejected the theory, either on scientific grounds or due to its perceived conflict with religious beliefs. Some critics accused Darwin of promoting a materialistic worldview that undermined the role of a divine creator. The public reaction was equally mixed. While the book attracted widespread interest and debate, it also provoked controversy, particularly among religious groups. Clergymen and theologians were divided, with some condemning Darwin's ideas as heretical and others seeking to reconcile evolution with their faith. The infamous caricature of Darwin as an ape, intended as ridicule, reflected the cultural unease surrounding his theory. Despite the initial opposition, Darwin's ideas gained traction over time. By the late 19th century, evolutionary theory had become a cornerstone of biological science, thanks in large part to the growing body of evidence that supported Darwin's claims. The synthesis of genetics with evolutionary biology in the 20th century further solidified the foundation laid by Origin, cementing Darwin's legacy as one of the most important figures in scientific history. The publication of On the Origin of Species was more than an academic achievement. It was a profound challenge to humanity's understanding of its place in the natural world. By proposing a mechanism for evolution that required no supernatural intervention, Darwin fundamentally altered the way scientists and the public viewed life's diversity and interconnectedness. In the end, On the Origin of Species achieved far more than its author could have imagined. It not only transformed biology, but also sparked enduring debates about science, religion, and the nature of human existence. Darwin's work, bold in its vision and meticulous in its execution, remains a testament to the power of careful observation, critical thinking, and intellectual courage. The publication of Charles Darwin's On the Origin of Species in 1859 was not only a milestone in biological science, but also a transformative event with far-reaching implications for philosophy, religion, and society. While the scientific community grappled with the mechanisms and evidence for evolution, the broader public engaged with Darwin's ideas in ways that would reshape cultural and intellectual discourse. This chapter examines the immediate and long-term impacts of Darwin's theory on science and society, exploring both its revolutionary insights and the controversies it provoked. Darwin's theory of natural selection fundamentally redefined the study of biology. Prior to the publication of Origin, biology was largely descriptive, focused on cataloging species and their characteristics. Darwin introduced a unifying framework that explained the diversity of life as the product of natural processes. Evolutionary theory provided a scientific explanation for the adaptation of organisms to their environments and the emergence of new species. It also offered a coherent account of the fossil record, which revealed a progression of life forms over time, and of biogeographical patterns, such as the unique species found on islands. One of Darwin's most significant contributions to science was his emphasis on the interconnectedness of all life. By proposing that all species shared a common ancestry, Darwin placed humanity within the continuum of the natural world. This idea challenged the anthropocentric view that had dominated Western thought for centuries, presenting humans as a product of the same evolutionary processes that shaped other organisms. This shift in perspective laid the foundation for modern fields such as genetics, ecology, and evolutionary psychology. The scientific response to Darwin's theory was mixed, but ultimately transformative. While many naturalists were persuaded by the evidence Darwin presented, others found the concept of natural selection difficult to accept. Critics argued that the theory lacked a mechanism for inheritance, a gap that Darwin himself acknowledged. This limitation was addressed later with the rediscovery of Gregor Mendel's work on genetics, which provided the missing piece in the puzzle. The synthesis of Darwinian evolution with Mendelian genetics in the early 20th century, known as the modern synthesis, solidified evolution as the cornerstone of biological science. Beyond science, Darwin's theory had profound implications for philosophy and religion. By explaining the complexity and diversity of life through natural processes, Darwin challenged the notion of a divine creator directly responsible for the design of species. This idea sparked intense debate among theologians, philosophers, and the public. For some, Darwin's theory undermined religious doctrines that viewed humanity as a special creation. For others, it presented an opportunity to reinterpret faith in light of scientific discoveries, leading to efforts to reconcile evolution with religious belief. The societal impact of Darwin's theory extended beyond the realm of ideas. It influenced debates on human nature, ethics, and social structures. The concept of natural selection was appropriated, and often misinterpreted, to justify various social and political ideologies. The term survival of the fittest, coined by philosopher Herbert Spencer, was used to support social Darwinism, a controversial movement that applied evolutionary principles to justify social hierarchies, imperialism, and eugenics. These misapplications of Darwin's ideas often distorted his original intent and highlighted the potential for scientific theories to be co-opted for ideological purposes. Darwin's work also inspired profound changes in education and public discourse. Evolutionary theory became a central topic in biology curricula, shaping the way generations of students understood the natural world. The debate over teaching evolution in schools, which continues in some parts of the world, reflects the enduring tension between scientific and religious perspectives on the origins of life. Darwin's ideas have also influenced popular culture, inspiring works of literature, art, and media that explore themes of adaptation, survival, and interconnectedness. In the arts and humanities, Darwin's theory encouraged a shift toward naturalism and realism. Writers, artists, and philosophers began to explore themes of struggle, change, and the influence of environment on human behavior. The idea that humans were part of an evolving, dynamic world resonated with intellectual movements such as existentialism and modernism, which questioned traditional beliefs and sought to understand humanity's place in a rapidly changing society. While Darwin's ideas faced initial resistance, their acceptance grew over time as evidence for evolution accumulated. Discoveries in paleontology, genetics, and molecular biology provided powerful support for the theory of evolution, reinforcing its central role in the life sciences. Today, Darwin's work remains foundational, guiding research into fields as diverse as medicine, conservation, and artificial intelligence. The impact of Darwin's theory on society is evident in its enduring relevance. The questions it raises about the origins of life, the nature of humanity, and the forces shaping the world continue to provoke inquiry and debate. Evolutionary theory has become a symbol of scientific progress and intellectual courage, embodying the pursuit of knowledge in the face of uncertainty and controversy. In conclusion, the publication of Darwin's On the Origin of Species marked the beginning of a new era in science and society. Its insights revolutionized biology, challenged established beliefs, and inspired a re-evaluation of humanity's place in the natural world. Despite the controversies it sparked, Darwin's theory has endured as one of the most influential ideas in history, shaping the way we understand life and its remarkable diversity. The impact of Darwin's work extends far beyond the pages of his book, influencing not only science, but also the broader human experience. The legacy of Charles Darwin's theory of evolution through natural selection is vast and multifaceted, extending well beyond the biological sciences to influence many other fields of study. As a cornerstone of modern scientific thought, Darwin's ideas continue to guide research, spark innovations, and deepen our understanding of life. This chapter examines how Darwin's legacy has shaped contemporary science, exploring its applications in various disciplines and the enduring impact of his revolutionary ideas. In biology, Darwin's theory provides the unifying framework that connects all life sciences. Evolutionary theory explains the origins of biodiversity, the relationships between species, and the mechanisms of adaptation. Fields such as genetics, ecology, and developmental biology all rely on evolutionary principles to interpret data and generate hypotheses. The discovery of DNA in the 20th century provided molecular evidence for Darwin's ideas, revealing the genetic basis of heredity and variation. Techniques such as genome sequencing now allow scientists to trace evolutionary lineages with unprecedented precision, confirming and expanding upon Darwin's foundational insights. One of the most significant applications of Darwinian principles in modern science is in medicine. Evolutionary biology has illuminated the dynamics of pathogens, helping researchers understand how bacteria and viruses adapt to their environments. This knowledge is critical in addressing challenges such as antibiotic resistance and the emergence of new diseases. The rapid evolution of pathogens highlights the importance of viewing health through an evolutionary lens, enabling scientists to predict and counteract changes in disease-causing organisms. Darwin's ideas have also profoundly influenced conservation biology. As ecosystems face increasing threats from human activity, understanding the evolutionary relationships between species is essential for developing effective conservation strategies. Evolutionary theory helps identify keystone species, assess genetic diversity, and design protected areas that preserve ecological processes. By recognizing the interconnectedness of life, conservation efforts rooted in evolutionary biology aim to maintain the resilience and stability of ecosystems in the face of environmental change. In the field of agriculture, Darwin's insights have been applied to improve crop and livestock production. Plant and animal breeders have long used artificial selection to enhance desirable traits, a process Darwin cited as analogous to natural selection. Modern genetic engineering and selective breeding techniques continue to draw on evolutionary principles to develop pest-resistant crops, optimize yield, and create sustainable agricultural practices. These innovations highlight the practical value of Darwin's ideas in addressing global food security challenges. Darwinian principles have extended their influence into psychology and behavioral sciences, giving rise to fields such as evolutionary psychology and sociobiology. These disciplines explore how natural selection has shaped human behavior, cognition, and social structures. By examining the evolutionary origins of traits such as cooperation, aggression, and mate selection, researchers aim to uncover the biological underpinnings of complex human behaviors. While these fields are not without controversy, they underscore the far-reaching implications of Darwin's theory for understanding the human experience. In paleontology, Darwin's theory has provided a framework for interpreting the fossil record, revealing the history of life on Earth. Fossils document the gradual changes in species over time, supporting the concept of descent with modification. Discoveries such as transitional fossils, which bridge the gaps between major groups of organisms, provide tangible evidence for evolution. The study of extinct species not only enriches our understanding of the past, but also informs predictions about the future trajectory of life on Earth. Darwin's legacy extends to interdisciplinary fields such as systems biology and bioinformatics, where evolutionary principles guide the analysis of complex biological networks. These fields integrate data from genomics, proteomics, and metabolomics to understand how life operates at multiple levels of organization. By applying evolutionary algorithms and modeling techniques, scientists can simulate processes such as protein folding, metabolic pathways, and ecosystem dynamics, advancing our knowledge of biology's most intricate systems. Beyond the natural sciences, Darwin's ideas have influenced fields such as economics, anthropology, and computer science. Evolutionary game theory, for example, applies principles of competition and cooperation to study human decision-making and social behavior. In computer science, evolutionary algorithms mimic natural selection to solve optimization problems, demonstrating the versatility of Darwinian principles in addressing complex challenges across diverse domains. While Darwin's theory has been widely validated and expanded upon, it continues to evolve as new discoveries emerge. Advances in epigenetics, for instance, reveal how environmental factors can influence gene expression, adding complexity to our understanding of heredity and adaptation. The study of horizontal gene transfer and symbiosis challenges traditional views of evolution as a strictly vertical process, highlighting the intricate ways in which life evolves. In conclusion, Darwin's legacy in modern science is both profound and enduring. His theory of evolution through natural selection has become a cornerstone of scientific inquiry, providing a framework for understanding the diversity and complexity of life. From medicine to conservation, from psychology to computer science, Darwinian principles continue to inspire innovation and shape our understanding of the world. The ongoing refinement and application of Darwin's ideas ensure that his legacy remains not only relevant, but essential to the advancement of knowledge in the 21st century and beyond. Darwin's intellectual courage and scientific rigor remind us of the transformative power of curiosity, evidence, and critical thinking in the pursuit of truth. Despite the scientific rigor and explanatory power of Charles Darwin's theory of evolution through natural selection, it has not been free from controversy or misunderstanding. From its inception in 1859 to the present day, the theory has faced challenges on scientific, philosophical, and theological fronts. These debates have shaped its reception and application, influencing how Darwin's ideas are understood and taught. This chapter explores the controversies surrounding Darwin's theory, focusing on its critics, misapplications, and the persistence of misconceptions. When On the Origin of Species was published, it challenged the prevailing worldview of creationism, which held that species were individually designed by a divine creator and were immutable. Darwin's assertion that life evolved over vast periods of time through natural processes was perceived by many as a direct challenge to religious doctrine. This tension sparked heated debates, particularly between scientists and theologians. Critics argued that Darwin's theory was atheistic, ignoring the possibility of divine intervention. Others attempted to reconcile evolution with their faith, proposing that natural selection was a tool used by God to shape life. Philosophical objections to Darwin's theory often centered on its implications for human nature and morality. The suggestion that humans were not separate from, but rather part of the natural world unsettled many, as it contradicted the belief in humanity's unique and special status. Critics worried that Darwin's ideas undermined traditional notions of purpose, meaning, and moral responsibility. These concerns were amplified by the association of Darwin's theory with materialism, the idea that natural processes alone govern the universe, leaving no room for spiritual or supernatural forces. Scientific criticisms of Darwin's theory emerged from several quarters in its early years. Some argued that natural selection was insufficient to explain the complexity and diversity of life, while others pointed to gaps in the fossil record as evidence against gradual evolution. One of the most significant challenges was the absence of a known mechanism of inheritance. Without understanding how traits were passed from one generation to the next, critics contended that Darwin's theory lacked a solid foundation. This gap was later addressed by the discovery of genetics, which provided the missing link between variation and inheritance. Perhaps the most problematic aspect of Darwin's legacy has been the misapplication of his ideas. Social Darwinism, a movement that arose in the late 19th century, misused the concept of survival of the fittest to justify social and economic inequalities. Advocates of social Darwinism argued that competition and struggle were natural and desirable in human society, using these principles to rationalize colonialism, imperialism, and eugenics. These distortions of Darwin's ideas were not based on his work, but were instead ideological constructs that co-opted his terminology. The concept of eugenics, which aimed to improve the genetic quality of human populations through selective breeding, also drew on a misinterpretation of evolutionary theory. While Darwin himself was skeptical of applying natural selection to human societies in this manner, his cousin Francis Galton promoted eugenics as a means of guiding human evolution. The movement led to ethically abhorrent practices, including forced sterilizations and discriminatory policies, which cast a shadow over the legacy of evolutionary theory. Another persistent controversy revolves around the teaching of evolution in schools. In some countries, particularly the United States, debates over evolution have taken the form of legal and educational battles. Opponents of evolution, often motivated by religious beliefs, have sought to introduce alternatives such as creationism or intelligent design into science curricula. These movements argue that evolution is just a theory and advocate for presenting it alongside religious explanations, despite the lack of scientific evidence for these alternatives. Misunderstandings of Darwin's theory also persist within the scientific and general communities. For example, the phrase survival of the fittest, popularized by Herbert Spencer, is often misconstrued to mean the strongest or most aggressive individuals prevail. In reality, fitness in evolutionary terms refers to an organism's ability to survive and reproduce in a specific environment. Similarly, the idea that evolution is a linear progression toward greater complexity or perfection misrepresents the nuanced and non-directional nature of evolutionary change. The rise of pseudoscientific claims, such as those made by proponents of anti-evolution movements, has further complicated the public's understanding of Darwin's work. The spread of misinformation through social media and other platforms has created challenges for science communication. Efforts to counter these misconceptions involve not only presenting the evidence for evolution, but also addressing the philosophical and theological concerns that fuel resistance to Darwin's ideas. Despite these controversies, Darwin's theory of evolution remains one of the most robust and well-supported frameworks in science. Advances in genetics, paleontology, and molecular biology have provided overwhelming evidence for the processes Darwin described. However, the persistence of debates underscores the broader cultural and philosophical implications of his work, which continue to provoke reflection and discussion. In conclusion, the controversies and misunderstandings surrounding Darwin's theory highlight its profound impact on science and society. While critics and misapplications have complicated its legacy, they have also spurred dialogue and further inquiry. Darwin's ideas continue to challenge humanity to reconsider its place in the natural world, fostering an ongoing engagement with questions of origin, purpose, and identity. The enduring debates over evolution underscore the complexity of scientific ideas and their intersection with cultural, philosophical, and religious beliefs. The influence of Charles Darwin's theory of evolution extends far beyond the confines of biology and the scientific community, permeating various aspects of contemporary thought and culture. Since the publication of On the Origin of Species, Darwin's ideas have reshaped not only our understanding of the natural world, but also how we view human existence, ethics, and society. This chapter explores the diverse ways in which Darwin's evolutionary theory has left its mark on modern philosophy, literature, art, and popular culture, as well as its implications for contemporary thought. One of the most significant areas impacted by Darwin's work is philosophy. Prior to the advent of Darwinian evolution, many philosophical systems were grounded in the belief that human beings were unique, distinct from other creatures, and endowed with a divine purpose. Darwin's theory, which placed humans within the same continuum of life as other species, disrupted these ideas, leading to a re-evaluation of humanity's place in the world. Philosophers grappled with the implications of Darwin's theory, questioning the nature of human consciousness, free will, and morality. Existentialists such as Jean-Paul Sartre and Friedrich Nietzsche, for instance, challenged traditional notions of a higher meaning or purpose, emphasizing human agency and the search for meaning in a universe shaped by blind natural forces. Darwin's theory also catalyzed the development of the philosophy of naturalism, which posits that everything in the universe, including human behavior, can be explained through natural processes without the need for supernatural intervention. This approach to understanding the world became a dominant perspective in the 19th and 20th centuries, influencing thinkers in ethics, metaphysics, and epistemology. The implications for ethics were particularly profound, as Darwin's ideas led to the rise of evolutionary ethics, which seeks to understand morality in terms of evolutionary processes, such as the role of cooperation and altruism in survival. In the realm of literature, Darwin's theory inspired a shift toward realism and naturalism, movements that sought to depict human beings as products of their environment, biology, and social context. Writers such as Thomas Hardy, George Eliot, and Émile Zola incorporated evolutionary ideas into their works, exploring themes of survival, heredity, and the struggle for existence. The notion that individuals are shaped by both nature and nurture resonated deeply with authors who sought to depict characters as products of their genetic inheritance and their environmental circumstances. Darwin's influence on art can also be seen in the shift toward depictions of the natural world in more scientific and detailed terms. Artists began to embrace naturalism, focusing on the accurate representation of animals, plants, and landscapes. The fascination with human evolution and the depiction of the missing link between humans and primates became subjects of artistic exploration, illustrating society's growing interest in understanding humanity's origins. The visual arts began to reflect an understanding of life as a dynamic, ever-evolving process, rather than as a static creation. In addition to literature and art, Darwin's theory had a profound effect on psychology and the understanding of human behavior. The rise of evolutionary psychology in the 20th century sought to explain human behavior in terms of evolutionary pressures and survival strategies. Pioneers of this field, such as William James and Sigmund Freud, integrated Darwinian concepts into their theories of human consciousness, emotion, and motivation. The notion that human instincts, behaviors, and social structures were shaped by evolutionary forces laid the groundwork for the study of psychology as a scientific discipline. Darwin's ideas also sparked the emergence of sociobiology, a field that applies evolutionary theory to the study of social behavior in both humans and animals. Sociobiologists like Yo Wilson argued that many aspects of human social behavior, such as cooperation, aggression, and mating patterns, could be understood through the lens of evolution and natural selection. This approach emphasized the role of biology in shaping not just individual behavior, but also social structures, suggesting that the biological basis of behavior could explain the development of cultures and societies. In popular culture, Darwin's theory has left an indelible mark on how we view humanity, its origins, and its future. The idea of evolution has been depicted in countless books, films, and television shows, often dramatizing the conflict between science and religion. For example, the portrayal of dinosaurs in prehistoric life in films like Jurassic Park and in popular media has sparked public fascination with the idea of evolutionary time and the extinction of species. Additionally, the concept of the missing link has been the subject of widespread interest, influencing the portrayal of human evolution in movies, documentaries, and books. Even in the modern age, when the scientific community widely accepts evolutionary theory, Darwin's ideas continue to fuel debates on a variety of fronts. In the field of bioethics, for example, discussions surrounding genetic engineering, cloning, and human enhancement are often framed in terms of evolutionary theory. The idea that human beings can alter their own biology and influence the course of evolution raises complex ethical questions about the limits of scientific intervention and the potential consequences of such actions. Darwin's work serves as a foundation for these debates, as society considers the moral implications of using evolutionary principles to guide technological advancements. Moreover, the persistence of anti-evolution movements, especially in some parts of the United States, underscores the ongoing cultural and ideological tensions surrounding Darwin's theory. Despite overwhelming evidence supporting evolution, certain religious groups continue to resist the teaching of evolutionary biology in schools, advocating for the inclusion of creationism or intelligent design. These debates not only highlight the cultural divide between scientific and religious communities, but also underscore the ways in which Darwin's theory has become emblematic of broader societal struggles over knowledge, authority, and worldview. In conclusion, Darwin's theory of evolution has profoundly shaped contemporary thought and culture, influencing fields as diverse as philosophy, literature, psychology, and popular media. His ideas have led to a rethinking of human nature, morality, and society, challenging traditional beliefs and fostering new ways of understanding the world. The legacy of Darwin's theory is not limited to the scientific realm. It continues to inspire inquiry, reflection, and debate in many areas of human life. Darwin's work remains a powerful force in shaping our collective consciousness, compelling us to reconsider who we are, where we come from, and what our place is in the ever-changing natural world. As we progress further into the 21st century, the significance of Charles Darwin's contributions to science and society remains undeniable. The central tenets of his theory of evolution through natural selection have not only survived, but have thrived, with new discoveries continuously reinforcing the validity of his ideas. This chapter explores the enduring relevance of Darwin's legacy in modern science, society, and global challenges, highlighting how his groundbreaking work continues to shape our understanding of the natural world and inform contemporary issues. At the core of Darwin's lasting influence is the ongoing development of evolutionary biology. As research in genetics, genomics, and molecular biology advances, Darwin's theory provides a robust framework for interpreting the vast amount of data generated by these fields. The discovery of the human genome, the sequencing of the DNA of countless species, and the study of genetic mutations and adaptations have all provided tangible evidence of the evolutionary processes that Darwin proposed. The modern synthesis, which integrates Darwinian evolution with Mendelian genetics, remains the cornerstone of biological research, guiding studies in everything from medicine to ecology. The continued exploration of the human genome, in particular, highlights the deep connection between human beings and other species. Genetic research has shown that humans share significant portions of their DNA with chimpanzees, our closest living relatives, and other organisms, providing compelling evidence for common ancestry. This genetic evidence has helped confirm the central idea in Darwin's theory that all species are interconnected through evolutionary history. As scientists continue to map the genomes of different species, they uncover new insights into the processes that have shaped life on Earth, reinforcing Darwin's original insights and revealing the intricate mechanisms behind natural selection. The application of Darwinian principles extends beyond the laboratory and into real-world challenges. In medicine, for example, understanding the evolutionary dynamics of viruses, bacteria, and other pathogens has become increasingly important in the fight against infectious diseases. The rapid evolution of antibiotic-resistant bacteria, as well as the emergence of new strains of influenza and the ongoing evolution of the COVID-19 virus, underscores the importance of evolutionary biology in public health. By studying the evolutionary patterns of these pathogens, scientists can predict how they may evolve, leading to more effective treatments and vaccines. Moreover, the fields of conservation biology and environmental science are deeply influenced by evolutionary theory. As biodiversity declines at an alarming rate, largely due to human activity, understanding the processes of evolution is crucial for developing conservation strategies. Darwin's insights into adaptation and the relationships between species have informed efforts to preserve endangered species and ecosystems. Evolutionary principles are now used to guide decisions about habitat restoration, genetic diversity, and the management of threatened species. In a rapidly changing world, where climate change poses an existential threat to many species, evolutionary biology provides a critical lens through which we can understand and mitigate the effects of environmental stressors. Darwin's legacy also persists in the realm of ethics and social theory, influencing contemporary debates on human nature, morality, and society. The rise of evolutionary ethics, which seeks to explain human morality in terms of evolutionary survival mechanisms, continues to shape discussions on topics such as altruism, cooperation, and justice. By studying the evolutionary origins of these behaviors, scientists and philosophers seek to understand how moral systems might have evolved to promote social cohesion and survival. While this approach remains contentious, it reflects the continuing impact of Darwin's ideas on our understanding of what it means to be human. In addition to ethics, Darwin's work has implications for broader philosophical questions about determinism, free will, and the nature of consciousness. As neuroscience and psychology advance, the question of how much of human behavior is shaped by biology versus environment remains central. Evolutionary psychology, which applies Darwinian principles to human cognition and behavior, provides a framework for understanding how certain psychological traits may have evolved to serve adaptive purposes. However, this field has also faced criticism for oversimplifying human behavior, and debates over the extent to which evolution shapes our mental processes continue to be a subject of lively discussion. Darwin's influence is also evident in the ongoing debates surrounding the intersection of science and religion. While many religious groups continue to reject evolutionary theory in favor of creationist beliefs, Darwin's work has also prompted a rethinking of religious doctrines. The notion of evolution as a natural, undirected process has led some religious thinkers to embrace the idea of theistic evolution, which holds that God works through natural processes such as evolution to shape life on Earth. This reconciliation of science and religion reflects the broader impact of Darwin's ideas on how humanity approaches questions of meaning, purpose, and the origins of life. Moreover, Darwin's theory has profoundly shaped the way we view the natural world and our place within it. The recognition that humans are part of a vast, interconnected web of life has sparked a growing environmental consciousness, encouraging efforts to protect the planet and its ecosystems. Darwin's work challenges the notion of human exceptionalism, urging us to recognize our shared heritage with other life forms and the responsibility we have to protect the biodiversity that sustains life on Earth. As environmental issues such as climate change, deforestation, and species extinction continue to threaten the planet's stability, Darwinian principles offer a valuable perspective on how to approach these global challenges. In the realm of education, Darwin's theory remains a central tenet of science curricula worldwide. Despite ongoing resistance from certain religious and ideological groups, the overwhelming scientific consensus on evolution ensures that Darwin's ideas continue to shape the teaching of biology. The widespread acceptance of evolutionary theory in educational institutions reflects its foundational role in the sciences and its continued relevance to our understanding of life on Earth. Efforts to promote science literacy and critical thinking are increasingly important in countering misinformation and fostering an informed public capable of making decisions based on evidence. In conclusion, Charles Darwin's legacy remains as vital and relevant today as it was over 150 years ago. His theory of evolution through natural selection continues to inform and guide research across multiple disciplines, from biology to medicine to ethics. Darwin's work has not only transformed science, but has also reshaped our philosophical and cultural understanding of humanity's place in the natural world. As we face complex challenges such as climate change, global health crises, and the preservation of biodiversity, Darwin's theory provides a crucial framework for addressing these issues. His enduring influence is a testament to the power of scientific inquiry to expand our knowledge and deepen our understanding of the world around us.